Welcome folks if you haven't been here before. I see some people look like they might be new, which is great. That's the whole point of these showcase talks, is to get some new folks on the call. Let's see, do we have the, yeah, we need to drop the meeting notes in here. 1 second. All right, so I just dropped a link to a Google Doc that you should all be able to edit. And if you'd like, you can add your name and affiliation and GitHub handle. And just a reminder for the format of these meetings, we are going to have a 15-minute showcase talk that gets recorded. We're recording now, and we don't usually ask questions during the talk. The talk is usually about 15 minutes, but Tasha, if you go a little bit over, that's fine. We're not going to be cutting you off unless you go like 45 minutes, then we might.
Dang it, I was hoping for 45 minutes.
And so after the talk, then we stop the recording, and that recording goes and gets a DOI on Zenodo, and it goes on the Pangeo playlist. And so the recording stops, but then we have some discussion. So then you can save your questions till then. And the idea is that it's supposed to encourage more, whatever questions you'd like to ask without worrying that they are getting recorded. And you know, if you feel like it was a stupid question, that there are no stupid questions though. And then so after that, then we'll go to the 1-minute roundtable with whatever we have, whatever time we have left. And you're encouraged to, if you'd like, but it's not required, to give a 1-minute update on what you're up to, or something you think the community might be interested in. Yeah, and then usually on the showcase talks, that's about all that we have time for. But if we happen to run out of check-ins, then we can move to any like longer discussion topics that people have. You can put those in like an agenda item, or we can just freely discuss something that popped up that we need a little more time for. Okay, so with that, let's get started. So we have a talk today by Tasha Snow, and she's going to talk about CryoCloud. And well, I think I'll just leave it there and let you share your screen and introduce yourself.
Okay, let's get this up. All right, is everyone seeing the full screen view?
Yeah, it looks great.
Sweet. All right. Yeah, thanks, Rich. Thanks for having me here. My name's Tasha Snow, and I'm a postdoc at the Colorado School of Mines. And I'll be talking to you guys about CryoCloud, which is a cloud computing platform that we're using for cryosphere communities, much
Tasha,
like the one you. Can you hear me?
Yes, we're seeing the real-time transcription. Is that intentional?
Yeah, is that okay?
Yeah, that's fine. I just wanted to make sure that that's what you wanted. I'm sorry. Go ahead.
Okay. Yeah, hopefully that helps with any needs that people might have. It's my first time using it actually, so but yeah, so CryoCloud is a cloud computing platform for cryosphere researchers, and it's much like the Pangeo cloud JupyterHub that you guys have. Before I dive into CryoCloud, I want to first recognize all of our collaborators on this work and our funders that are supporting us. So today I'll talk about what CryoCloud is and kind of some of the lessons we've learned so far from it. But before I dive in, just a little bit of background. CryoCloud is kind of coming out of this open science revolution that NASA has, and I know all of you are familiar with the Open Source Science Initiative and Transformed Open Science program. It's funded by TOPS as well as NASA Cryosphere. And it's really coming when NASA is having, or it's most of the CryoCloud innovation is happening in the year of open science 2023 that NASA has declared, and the US federal government now has joined up on, as well as a lot of federal agencies and academic institutions. So a lot of the work that we're doing will be happening in this first year, this year of open science. And a lot of the innovation and that we're providing for this push for open science is in cloud computing, which I know you all are very familiar with. Some of you may have been on this publication where Shel Genteman and others talk about how important the cloud is for open science and how it's changing the realm of possible questions we can ask. And it's both advancing science and inclusivity at the same time. And what we found, what y'all have found, I know that a lot of these tweets come from your community, is now we can start to process massive amounts of data from things like Raspberry Pis, $36 computer, from your cell phone or on a flight. So we're really democratizing science with the cloud, and it's part of why we stood up CryoCloud. And it's really in support of this need for a digital watering hole, because data is too large for our computers. It's from disparate sources. So by leaving it in the cloud and bringing our computing there, building our software there in the cloud, we can start to work together, going beyond disciplinary silos, bringing a bunch of participation from a lot of diverse communities, and ultimately connecting with society and impacting critical decision-making on timelines that are much faster than they used to be. Now, specifically for CryoCloud, this kind of originated from the ISAT-2 science team. ISAT-2 is a satellite that is a laser altimeter. It measures the surface of elevation of the Earth. And they have a science team that directs this mission for NASA, and it meets biannually. And in May 2022, we sat in on myself and Joanna Milstein, who is also on this call. She's the other person who helped design this project. We sat in on a cloud computing and open science panel where a lot of the science team expressed worries about cloud computing, in the fact that there were non-intuitive pricing structures, documentation was poor, computing options and infrastructure were not intuitive. It was costly to use, and people were finding that they were bringing up a lot of a huge bill without realizing it. They're worried about time to transition workflows, intellectual theft, and they weren't actually sure that it was more collaborative or faster. And based on Joanna and I's experience in using the cloud, this really didn't ring true to us. So we've used cloud, the Jupyter Meets the Earth cloud from Berkeley, that's stood up by 2I2C. And a lot of the reasons why we think our experiences were very different is because of 2I2C. And I think most people are familiar with 2I2C, the International Interactive Computing Collaboration. It's a nonprofit, provides JupyterHubs, and y'all work with them. So I think most of you are familiar with them. But because of how they contribute back to open source communities and their overall cloud expertise, that's why we worked with them and partnered up to create the CryoCloud. So CryoCloud is a cloud computing platform with bumpers. The goal of this project is to be a simple and cost-effective managed cloud environment that we're using for training and transitioning new users to cloud workflows, while also determining community best practices. And so the key there is kind of the social innovation that we're working towards, not just the technological part of like building the infrastructure for working in the cloud. We have built and developed CryoCloud for Cryosphere scientists, and it's built by 2I2C cloud experts to be able to make it possible to process data faster and to democratize science. Now, a lot of the uses of cloud computing platforms in the cryosphere have come through the hack weeks, which are small events. The clouds are shut down not too long after they're built, and so this disruption of science occurs because people have to move in and out of the cloud. And so one of the ways that we solve this is by providing a persistent platform for at least 3 years. Hopefully, if we prove that we're useful, we can keep it, get more funding and keep it for a lot longer. We are providing small and medium instances for all of our users with the option to bring your own AWS credits and use larger servers. And we're developing new tools. One tool, it will be the personal cost monitoring button or dashboard in JupyterHub, so that people don't accidentally ring up a lot of charge a lot of ring up a lot in cloud credits without realizing it. And we're also hoping to improve intra and inter-hub collaboration tools. So if you have multiple hubs, if you're working with people in other hubs or within your own, you can communicate and collaborate more easily. So a lot of this is focused on the cryosphere communities themselves, but we're also helping try to see to scale up and provide resources, platforms for larger communities. So we're taking community surveys, feedback, and providing guidance to them for them to be able to do that. From this project, what we've already built is a Jupyter book and also the JupyterHub, and that's found at cryointhecloud.com. So you can check it out there if you want to. We also have a GitHub. We have new hub tools that we're developing. We have the CryoCloud Slack, community office hours for having communication with our users. We're providing training, tutorials, and resources. One of the main thrusts for the work that we're doing is to provide workshops at some of the long-standing cryosphere workshops and conferences throughout this year to bring users onto our hub and to learn from them. And then that will all culminate in the AGU Year of Open Science in December. I'll talk a little bit more about some of those trainings in just a minute or two. We're also bringing in related cryosphere communities and working with them to share in infrastructure ideation and construction. So, for example, the Arctic Data Center is putting a lot of their data into the cloud, but some of the data isn't going into the cloud. And are there tools that we can develop with the Arctic Data Center that will allow us to access that more easily from CryoCloud? So those are kind of the questions that we're asking. As I mentioned, I wanted to share with you a bunch of lessons learned so far. I'm giving a talk right now, just as a heads up. Sorry. Yeah. Sorry, I'm in a room with a few other people. So we have a few lessons learned, and a lot of those are around social and technological innovation that I'll talk to in just a moment. And we really like to think about the fact, or we kind of recognize that social innovation provides most of the success that we get from total innovation, and it's not as much about the technological innovation. So we're working to do both and really focusing on how the community can work together. So we're really pushing for active engagement with the scientific community and building new community models, and working towards having continued assessment and feedback. And so I'll circle back to this at the end. So a little bit from our survey, we found that users expect they will be primarily computing in the cloud in the next 5 years. So on the left shows how much of their compute time is spent in the cloud. And what you'll notice is that today, that the number of people who barely use the cloud or don't use it at all is about 65 or 70%. And that's about the same percentage of people who expect to be using the cloud for the majority of their computing in 5 years from now. So our users really think that they'll be transitioning to the cloud in the next few years. They really buy into the cloud as the next technological advancement for their computing. They also found that their main motivations kind of revolve around data storage and downloading primarily. So they're most worried about the fact that their storage and processing speeds on their local computer are not sufficient. So they expect their analyses to also run faster, to have easier collaboration and development in the cloud as well. So those are kind of their motivations. We also found that our users have a wide range of expertise, and that this is really beneficial for working in these new environments. So we have an even distribution of knowledge of cloud-based workflows, past experience in the cloud, and knowing where to find resources. And this interaction between beginners and experts really helps to accelerate the learning curve of beginners. And this is something that's also been found in a lot of the hack weeks that have taken place through the eScience Institute. Our users stated that their biggest challenges in transitioning were both cloud expertise and costs. And CryoCloud takes care of the costs. And then this sort of model where we have experts and beginners together helps to take care of this cloud expertise. We really get to pool our expertise resources with this model. In polling our users, we also found that computing infrastructure needs to be flexible and modular to meet the unique needs of our communities. When we polled our users, we found that there's a wide range of languages that they're using. Python is the primary one that's being used, but there's a lot of MATLAB users as well. And a lot of those people plan to transition to more open source coding languages in using CryoCloud and doing more open science in the future, but that takes a lot of effort. I've talked to quite a few people offline who have not taken our training, who are not in the CryoCloud because they use MATLAB and don't have those kernels yet on CryoCloud. So we're working to actually build the infrastructure to have the MATLAB kernel within the CryoCloud and allow people to bring their own licenses, very similar to how OpenScapes does theirs. So people will be able to have a kernel selector as well as an image selector to allow them to have different environments. And we decided to do this even though this is an open science platform, because this helps to be more inclusive and to take into account that a lot of our users didn't have this idea of open science rolling around when they started their degrees or their careers a long time ago. So it's helping to shepherd them into the cloud and hopefully provide a space where they can transition their current workflows into things like Python or Julia. We also found that different kinds of users all in one place accelerates the feedback and collaboration that can take place in the cloud. We have developers from these different tools, IcePix and Earth Access in our cloud, as well as the users who use those tools and apply them to the data sets. And by having them in the same place, those tools can be tested immediately. We can get immediate feedback and everyone's working in the same environment. So it really accelerates that feedback loop and also improves the amount of collaboration, increases the amount of collaboration we can have between our scientists, and reduces the redundancy and reinventing the wheel that happens because everyone is communicating and working together to build some of these tools. We also found that a consistent platform provides a place where individuals and communities can rapidly mobilize when need arises. And this is really important in times where we have, a climate crisis or something where a team needs to mobilize quickly and come up with a scientific product that might be used for policymaking. A team like that could get onto the cloud within less than a day and be able to be doing their science. We can also provide this sort of infrastructure for events like I've shown here. These are ones that we planned in large lettering. The three at the bottom are ones that have joined in and will be using CryoCloud that we didn't originally expect to bring on. And what this means is we're sharing these resources, costs, and time. We don't need to spend that in the Cryosphere community anymore because we can pool that in the CryoCloud. And lastly, the cloud really democratizes science. And I think most of you understand this, but really all you need is a cheap laptop and an internet connection to be able to access powerful compute. And what that means is really early careers, underrepresented groups, and people from non-R1 academic institutions can now access some of these resources that wasn't possible previously. So kind of in closing, those were some of the innovations that we're thinking about, and I'm sure there's going to be a lot more going forward. But really the whole idea here with the cloud, thinking about open science, is that it's not a process, or it's not a product that we're trying to create here. It's more of a process. The social innovation is going to be really key in making cloud computing successful and reaching our open science goals. So with that, thank you. And I'll take any questions. Please visit cryointhecloud.com if you want to check out more.
Awesome. Thank you so much. That's really it's really cool. It's really cool how you're bringing that community along. And maybe I could just if you have a question, raise your hand, because we have quite a few people on here. Maybe I could just start off with the question though. How do you you mentioned like